Today I wanted to do a video about the electrical system that I'm putting in my Sprinter van. In particular, I wanted to talk a little bit about lithium batteries, why I chose lithium, and also maybe bring up some information that I felt should have been readily available to people for doing this themselves. It seems like there's a lot of misinformation out there, or not the kind of information that you need in order to determine how all of this is going to work together. Drawing from a lithium battery is one thing, but the techniques that you need to use and the equipment that you need to use in order to safely charge this equipment is definitely a subject that I wish there was more information out there about, so I thought we'd talk about that today. First, I want to talk about how I use my van. Depending on what type of camping you like to do, that's going to determine what kind of equipment that you need. And in the case of my van, I never go to RV parks that have shore power. Shore power just isn't something that's going to do any good for me. So I'm mostly at small campgrounds that don't have power, or I'm not at a campground at all. I'm boondocking. So shore power is sort of irrelevant to me. And that's not the case with most American RVs. All the RVs I looked at generally have one small house battery, no solar, and that works okay for a lot of Americans because a lot of Americans go to RV parks where there's shore power, but that doesn't work for me. So I need a different equipment, which includes the ability to charge on solar. I needed pretty decent battery capacity, so that's how I use my van. Another thing about the way that I use my van is typically I try and stay out of really hot climates, but I live in California. It does get warm. When I camp, I do tend to be parked under trees for shade, which isn't the best for solar production, but I also don't sit around at a campground for days on end. What I found is I drive my vehicle almost every day, but more like every other day. And what I've found is that if I am parked in the shade under a tree, and if those are conditions where I'm not getting a lot of sunlight and recharging the battery, the drives that I do to trailheads to go biking or hiking, this truck can sit in a parking lot for a couple hours in the sun and generally recoup enough energy to last for several days. So I haven't had much of an issue with shading, and that's mainly because I don't sit for a week on end. Just driving down the highway, I get charging on the solar, and same with going to trailheads. Generally there's sunlight available somewhere where I can keep the batteries topped off. So I'm going to give you a little peek at the setup that I have. And this is a lot of why I chose lithium, because it will fit in a pretty small space. The battery I'm using is 200 amp hours, and you can use 80% of a lithium battery's capacity, so that gives me about 160 usable amp hours. To have the equivalent power with a lead acid or AGM battery, you generally only want to draw those down about 50%, otherwise you start causing permanent impacts to lead acid or AGM's battery capacity. So in order to have 160 usable amp hours, I would need 320 amp hours of AGM battery, and that would not fit in a box in this size. So crammed in this box, I have a 1000 watt Magnum inverter with the battery below that. So I'll go ahead and right now I disconnected the Magnum so I could remove it. There are a positive and negative lead here that connect to the inverter. So I'm going to go ahead and lift that out so you can see what the battery looks like. Now that the inverter's out, you can see the battery. It's just over 19 inches long, 5.5 inches wide, and I think it's 7 inches tall. And like I said, it produces a net of 200 amp hours. And right now, the sole method of charging that I have is a 300 watt solar panel on the roof. I did another video on my solar, so you might want to look for that, for specifically for the solar. But basically what we have going on is this cable right here comes in from the solar, goes through a breaker, and then goes into the charge controller. And that converts the 40 volts DC that my panel produces and puts it into a voltage and amperage that the battery can use. And right now that is the only method of charging that I have. What I am planning to do is my inverter is also a charger, and so I'm going to have a second small vehicle inverter that takes the alternator power, it converts it to 120 volts, and it sends it through basically a really small power line back to this inverter charger that then charges the battery. And you could definitely argue that that's not an efficient way to do it, because you're taking 12 volt power, turning it into 120, sending it to the back, and then converting it back to 12. That's true. But at the same time, I found it very difficult to find chargers for lithium technology where you can set programmable charge points, and that's a really important point that we'll talk about later. But the Magnum charger does have programmable inputs, and so that allows me to take inverter power and plug it into this, and as far as the inverter knows, it's just shore power. But because my van right now does not have the walls installed, it makes sense for me to go ahead and run the wires so that I have that capability in the future. So far, solar has worked so well that I haven't needed that, but I might as well run the wires just in case I ever find that I have that need. So what we have here, kind of walk through some of the hookup. Now keep in mind, I'm not an electrical engineer. I'm just a guy with a van, so you should do this at your own risk. But there's a negative lead right here that comes off the battery. It goes through this shunt, and the shunt just counts basically the electrons to help you determine what your battery's state of charge is, how much is coming in from solar, and then how much is going out by your consumers. And then after the shunt, that negative just terminates here on a bus bar. So that's where all the negatives are tied. So that's it on the negative side. On the positive side, the positive lead comes off the battery terminal here. It goes through a 200 amp Class T fuse, and then it goes up into this Blue C 6006 series switch. And what this allows me to do is shut off the entire electrical system. So when my van is parked in the driveway, I have everything shut off, and this is how I do it. The second switch next to it just sends power to the inverter. So these are the two cables here that connect up to the inverter, and since I don't really have a lot of uses for my inverter, I am going to use it to run a small induction plate. That means my inverter does not get a lot of use. So I leave it shut off because it does have a little bit of a ghost draw. So also down here is a computer, a BMS, that runs the battery, and its main purpose is to disconnect the battery from the consumers if the battery gets down below 20%. If you get below 20%, or if you drag a lithium battery down too low, you can cause permanent damage to it. So the BMS prevents the battery from being over discharged, and it does that through this contactor right here. So everything runs through this. I should say all the loads run through this. So if the inverter was running, the refrigerator was running, and the battery determined that it was getting down below 20%, it would open that contactor, which is just like a heavy-duty relay, and it would disconnect all the loads, so it wouldn't cause damage to the battery. The other contactor next to it is called the overvoltage contactor, and what it does is if your charging sources, which in my case would be solar or my inverter charger when I get that hooked up, if they did not follow their program that I have programmed in, and they began overcharging the battery, the BMS would not allow that to happen. It would open this contactor, and all the charging sources would be disconnected. There's one other thing you see down here, and that's a fuse, and a circuit breaker. Both of these are for solar. This circuit breaker intercepts or fuses the line coming into the charge controller from the solar. And it also serves as a switch so that I can shut the solar off. And the second one down there is at twice the amperage, and that's because an MPPT charge controller boosts up the amperage. This is a 15 amp, that's a 30 amp. And so that protects the circuit downstream between the solar charge controller and the battery. The other thing I have in here is I have a small distribution block, because there are some consumers in here. The BMS needs its power supply, and there's also, this is temporary, there's an LCD screen that I can hook up. And the screen tells me all the battery stats. The battery is a GBS, Elite Power Systems battery. And so this display that you see is part of the kit. So the kit comes with the battery, comes with a shunt, the BMS, the LCD screen. Pretty much came with everything I needed except for the two contactors, which I bought separately. And the other nice thing is it gives you the voltage and temperature of each cell. So on a lithium, on a 12 volt battery, there's 4 cells in my battery, and you can see that each cell is within about 2/200ths of a volt of each other. So it's just a nice monitoring point. So the electrical system isn't done. This is where the battery's housed, where the inverter is housed, the solar, most of the hardware. Right now I have a refrigerator up and running, I have a max air fan, but I'm in the process of building my cabinetry, so I have not landed all the wiring yet. The way that's going to happen is the wiring is going to leave this box through those 2 blue tubes right there that go down under my floor and pop up on the other side. And my galley is going in on that side. There's a refrigerator in the beginning of the framing. So what will happen, the DC wiring will go through one, the AC wiring will go through the other. They'll pop up on the other side, and then there'll be a larger distribution block along with a circuit breaker panel that's over next to my galley, and that's where things like the water pump, the refrigerator, the lighting, all the consumers are actually going to be tied into a different distribution block over on the other side of the van. One of my biggest reasons for going lithium is the physical size. So I have a seat that slides on rails 8 feet, and the seat stops about 3 inches short of what you see here. That's the way these rails come from a VW California overseas, and that's just how they're set up. They don't run all the way back to the end of the rails, so they stop right before this box. And the other thing is this seat back folds down to make a bed, and so I couldn't go any higher than this box because this is the height the seat comes down and forms a perfectly level sleeping area at that point. So had I gone with anything wider or taller, it would have restricted my seat movement, and it would have made my bed not lay flat. So those were, I also, the sliding seat, for all the advantages that it has, the disadvantage is that you can't use this entire side of the van. With it sliding, it means that you can't have tall cabinetry sitting there. So this otherwise would have been wasted space. So it allowed me to use this space and at the same time to balance some weight in the vehicle, get some of the weight of the inverters and batteries over on this side. Because on this other side, I'm going to have all of my cabinets, refrigerators, all that. So it's sort of a balancing act. All right, charging. So you need, if you're going to run a lithium battery, you need to use equipment that is either meant for lithium, which there are very few products out there that I could find, at least as of the time of this video, which is September 2017. So what you need is equipment that has programmable charge points. So I'm using the Victron 100, which means it'll take a panel that's up to 100 volts. Mine's 39, 40 volts, and up to 30 amps. My panel, it produces up to 9.9 amps, but the MPPT turns that into about 20 amps. So this solar charge controller, I'll have to insert some screenshots later because I'm using my phone to film this video. But the Victron has this Bluetooth receiver right here. So using an app on my smartphone, I'm able to see what's coming in on the solar, and using that same app I can set programmable charge points. And as an example, this battery is considered 100% full at 14.2 volts, and most lead-acid batteries, that number is more like 14.6 to 14.8. So that's why you can't use lead-acid equipment on lithium, because the charge requirements are different. So with the Victron, the way I do it, and again, I'm not a professional on batteries and everything else, but what I do know about lithium is, unlike lead acid, they don't need to be fully charged, and in fact they don't really want to be fully charged. So I don't need the extra battery capacity. So what I do is I charge my battery to somewhere in the low 90% range, and I do that by setting the charge controller to terminate bulk charging at 13.8 volts. And again, 14.2 is considered full on this battery. 13.8 gets me in the low 90%. These batteries don't really need an absorb cycle, so I have absorb set to a minute or a couple minutes. I don't remember exactly. And then I have this battery float at 13.5 volts. And that's another controversial subject, is the float. Because they say that lithium batteries do not like to be floated. But when you're charging solely on solar, if you don't allow the battery to float, then you're not taking advantage of the sun when it's out. So my scenario is that my battery is generally full by late morning, early afternoon, and when it switches to float mode, it maintains my battery at that roughly low 90% range, but yet it picks up the loads from my fridge, my fan, whatever else is running, so that by the time the sun goes down, my battery is still full. So that's why I float my battery. And you may decide to do something different, but this is what works well for me. And then we talked a little bit about the Magnum inverter charger. It also has programmable set points. It's not as programmable as a Victron. It's not as programmable as I would like, but it is one of the few inverter chargers where you can go in and set different ranges for the battery to charge the bulk, absorb, and float cycles for the battery. So that's it for now. I mainly wanted to give you guys a little bit of background on how I use my van, why I chose lithium, at least gave you a glance at how I have this hooked up and what equipment I'm using to charge it. That's the biggest struggle that I had when I was looking at lithium, was trying to find equipment that could safely charge a lithium battery. I was not able to locate a lot of hardware that was meant specifically for lithium, and I had to look really hard to find equipment that had adjustable, programmable charge points, because that's probably the most important thing to take away from this video, is make sure you use equipment that will charge to, like, say, a lower voltage than what you'd have with lead acid. Lead acid wants to see 14.6 to 14.8 volts full charge. These batteries are more in the 14 to 14.2 volt. You're going to do a lot of damage and have a lot of bad things happen if you try and use lead acid equipment on lithium batteries. So I really like the Victron equipment. The Magnum inverter charger works for me. I don't have a lot of AC uses. Again, I've got a small induction plate that tops out at 1400 something watts, and you're probably thinking to yourself, well, your inverter only does 1000, and that's true, but the Magnum inverter does have a pretty good overhead. It'll run, I think it's peak 1750 watts for a short amount of time. It's like 5 seconds, and then it does 1600 watts for 30 seconds, 1250 watts for 30 minutes. I can't remember, but the point is that I did test the induction, and I'm able to, on a 1000 watt inverter, get it hot enough to do the things that I want to do, to cook or to boil water. So the small 1000 watt inverter is going to work well for me. It's also about half or maybe a third of the size of a 2000 watt inverter, and that was the biggest decision maker for me. Was this is the space I had to work with, so I had to use equipment that would fit in the space. So that's it for now, guys. Thank you.